Welcome back to Astronomy Daily, your essential guide to the cosmos. I'm Anna.
And I'm Avery. Today we're covering Earth's magnetic field changes, ambitious plans for lunar deliveries, and a journey back in time to when our planet might have looked quite different.
It's a packed episode. Let's dive into the latest in space and astronomy news. All right, let's start with Earth's magnetic field. It's our planet's first line of defense, generated by the molten iron in our outer core, protecting us from solar wind.
Exactly. New data from the European Space Agency swarm satellites reveal significant ongoing changes within that shield.
Significant is right. The South Atlantic anomaly, a weak spot since 1958, is stretching eastward towards Africa.
It's stretching towards Africa, and a strong spot is growing over Siberia. The field is reorganizing.
These changes are from complex variations where the liquid outer core meets the mantle. We're seeing reverse flux patches where magnetic field lines point in the opposite direction.
Fascinating. A reversal. Not an impending catastrophic magnetic pole flip, right?
No catastrophe for life on Earth. The anomaly increases radiation for satellites, but poses no danger to us, shielded by the atmosphere.
Huge relief. But it's a big deal for space infrastructure.
Satellites in the South Atlantic anomaly need extra radiation hardening. Navigation systems also require constant updates as magnetic poles shift.
That makes sense. The northern magnetic pole moving towards Siberia is linked to the strengthening field there. Our planet's interior is dynamic, influencing GPS and space missions.
Precisely. It's a gradual geological process, not alarming for us, but something for space agencies to monitor.
All right, from Earth's deep interior, let's pivot to our closest celestial neighbor, the Moon. Impulse Space, an innovative company, has unveiled ambitious plans to haul significant cargo, up to 6 tons a year in fact, to the lunar surface.
6 tons of cargo? That sounds like a game changer for lunar exploration. What's the timeline?
They're aiming for deliveries as early as 2028. Impulse Space identified a gap for mid-sized lunar surface payloads from 500 kilograms up to 13 tons.
That's a substantial niche. Current focus is on small scientific payloads or massive missions.
Exactly. Their architecture involves a new lunar lander paired with their in-development Helios high-energy kick stage for efficiency.
A kick stage is a propulsion unit that gives a final boost, right?
That's right. It provides final trajectory and velocity. With this system, they project delivering up to 6 tons across 2 missions annually, at a cost-effective price, making lunar logistics more accessible.
6 tons across 2 missions. What types of payloads are they envisioning?
The possibilities are vast. Rovers, habitat modules, power generators, communication systems, lunar terrain vehicles, the building blocks for sustained human presence.
So, setting up infrastructure, not just experiments. How mature is Helios kick stage technology?
Helios is deep in development, with its first flight test slated for late 2026. By 2028, they anticipate multiple operational flights, rapidly ramping up delivery capabilities, signaling a new era for lunar logistics.
That's fantastic news for lunar exploration. Commercial entities filling these gaps make space exploration more dynamic. All right, let's shift gears and get to our rapid fire launch roundup from October 14th, 2025. Avery, you've got the latest from SpaceX, and it was another busy week for them.
Anna, busy barely covers it. As we reported yesterday, they kicked things off with Starship Flight 11 successfully deploying Starlink simulators. SpaceX is already transitioning to a new Block 3 design for Starship and Super Heavy booster. Talk about rapid iteration.
Wow, Block 3 already? Incredible pace. It shows their commitment to getting Starship fully operational quickly.
It really does. Falcon 9 had an insane week. 6 missions. 4 Starlink deployments, 1 Project Kuiper mission with weather delays, and a critical launch for the Space Development Agency.
6 Falcon 9 launches in 1 week? Mind-boggling. It underscores their dominance. How many Kuiper satellites are Amazon putting up now?
The Project Kuiper KF-03 mission launched 24 communication satellites, bringing their total constellation to 129, a significant chunk of their planned internet constellation already in orbit.
Mm-hmm. And the Space Development Agency mission is for national security, right?
That's correct. The Tranche 1 Transport Layer C mission for the Space Development Agency, part of building a resilient military satellite network, was delayed by weather, but rescheduled for Wednesday.
Any other notable Starlink missions or booster milestones?
Absolutely. Starlink Groups 10-52, 11-19, and 10-17 were on the manifest. Falcon 9 booster B1067 set a reuse record, completing its 31st flight. Astounding efficiency.
31. Unreal. It revolutionizes space access. What's been happening on the international launch scene?
Internationally, China has an active week with 4 launches, including a Changzheng 2D carrying the Shiyan-31 optical imaging demonstrator. Rocket Lab also had a successful Electron launch, deploying Synspective's Owl New World satellite.
So, from Starship to small sats, the global pace of space activity isn't slowing down. It's a great time to be following space news.
All right, Anna, let's turn our gaze to a celestial visitor, Comet C/2025 A6, known as Comet Lemon, which just had a vast section of its tail stripped away by the sheer force of the solar wind.
Wow, a comet interaction with the solar wind dramatic enough to tear off part of its tail. Who captured this stunning event?
Astrophotographer Brendan Gilmore snapped these images. Comet Lemon has been brightening with hope it could become a naked eye comet this October, nearing perihelion on November 8th.
A naked eye comet is always a treat. What did Gilmore's images reveal about the comet's appearance?
His images showed the glowing green coma and the long luminous tail. On October 2nd, a colossal section of that tail was stripped away by the solar wind.
That's a disconnection event where the plasma tail separates from the comet's head due to solar wind interaction.
Exactly. It's a powerful demonstration of the solar wind's force. Despite this shedding, Comet Lemon's brightness is around plus 5.1 magnitude, which means it's potentially detectable as a dim, fuzzy object to the unaided eye from dark sky locations.
That's incredible. It highlights the dynamic environment of our solar system. I hope some of our listeners get a chance to see it. Okay, Avery, brace yourself for a story that genuinely changes how we might picture our home planet's deep past. New scientific research is suggesting that early Earth, get this, may have once shimmered with a vibrant purple hue.
Purple? Our entire planet glowing purple? That sounds like something straight out of a fantastical sci-fi novel. How could our blue-green marble ever have looked so different?
It's an absolutely mind-bending hypothesis, but it makes a lot of sense when you look at the microbiology. The theory posits that early life on Earth might have been powered by retinol-based photosynthesis, which is a different mechanism than the chlorophyll-based photosynthesis that makes most plants green today.
Okay, so it has to do with how sunlight was absorbed. Chlorophyll reflects green light, which is why plants appear green to us.
Precisely. Now imagine retinol. This pigment found in ancient microorganisms, mostly archaea, like the halobacterium you see thriving in salt flats today, absorbs green and reflects red and blue wavelengths of light. When you combine red and blue, what color do you get?
Purple. So these early microbes coated the planet's surface, particularly in the oceans, and gave it this distinctive purple color? That's wild.
Exactly. This purple Earth phase is thought to have largely predated the Great Oxygenation Event, a pivotal moment in Earth's history when oxygen levels in the atmosphere began to rise dramatically. In those early low oxygen conditions, retinol-based photosynthesis would have actually been more efficient than chlorophyll-based photosynthesis.
That makes a lot of sense. An evolutionary adaptation to the early Earth's unique atmospheric conditions. Do we have direct fossil evidence of these purple microbes from billions of years ago?
Direct fossil evidence of the purple color specifically is still elusive, which isn't surprising given how ancient this period is, but extensive biochemical analysis of modern archaea, which use retinal, strongly supports this hypothesis. It suggests that a purple planet wasn't just a quirky theoretical possibility, but a widespread and very successful biological strategy for early life.
Wow, so this isn't just a fascinating historical curiosity. Could such conditions ever resurface?
Potentially, retinal-based systems are incredibly resilient and still exist today. Researchers believe they could absolutely resurge under specific environmental pressures, such as a significant decline in atmospheric oxygen levels, though that's a very distant hypothetical for our planet.
And I imagine this theory has massive implications for astrobiology, right? When we're looking for life beyond Earth?
Absolutely, it reshapes our search. It means that when we're analyzing the light signatures from distant exoplanets, a faint purple hue rather than just a green one could actually be one of the earliest and most compelling indicators of life. It vastly broadens our definition of what a living planet might look like.
That is truly mind-blowing. A purple Earth in our past and potentially purple exoplanets in our future. What a perfect note to end on.
That wraps up another packed episode of Astronomy Daily. From Earth's magnetic field to lunar cargo, comet tails, and a purple Earth past, the cosmos never ceases to amaze us.
It certainly doesn't. Thanks for joining us for these cosmic updates. We hope you enjoyed diving into space and astronomy with us.
Find Astronomy Daily wherever you get podcasts, subscribe, leave a review, and share your favorite stories. And of course, for even more space and astronomy news, simply visit our website at astronomydaily.io. This is Anna signing off. See you again tomorrow.
And this is Avery. Until next time, keep your eyes on the skies and keep looking up.